Hi everyone, my name is Anna Zharkova, and today I would like to present my talk about Kotlin Native, dealing with old and new memory model. Uh, Thank you for introduction. I'm also a Kotlin GDE and Woman Technique ambassador since last year, and also I'm a tutor of iOS in special courses in Otis platform. So let's begin. Today we will discuss about Kotlin Multiplatform and common concurrency. Then we will speak about coroutines, solving problem in Kotlin Native. For everyone, coroutines and Android is something really common, but for Kotlin Native there is a lot of different nuances. Then we will speak about such native mechanism as background workers, advanced sharing, and also, I would like to present some slides about how to use Kotlin Native and flows in iOS side. To use a mechanism that's special for Android or Kotlin multiplatform. So let's begin. Kotlin Multiplatform is a special SDK for cross-platform development, and it was developed by JetBrains company. It is a special kind of common model of your code, and you can put and share all the common code here, and then this model will be compiled differently with LLVM as a framework for iOS application and as a jar by GVM for Android application. So you have one common model and you can use it with several targets. And you can specify and share the most of your code except of UI or maybe some special platform specific code that should be implemented only in native parts. It could be also managed from common model, but there is a lot of tricky moments, and we also will speak about it. One of the speciality of Kotlin multiplatform, it uses different version of Kotlin in every part of its common model. For example, in common main, it uses Kotlin common, and then in Android main, for using and managing with Android and Java code, it uses Kotlin GVM, and it uses Kotlin native for iOS or desktop. And also, if you will specify a target as a web application, it need to use Kotlin JS. So there is a lot of version of Kotlin native and some kind of common version. And we understand that iOS is different and Android is different. So there will be something really hard with doing some common moments. To manage common code and to specify differently for iOS and Android, there is a mechanism of expect actual. We need to define something we need to implement differently for iOS and Android as expect, and then we specify and implement it as actual in Kotlin native and in Kotlin JVM. You need to implement in every target you will specify, even when you don't need this implementation. You can add and use some kind of third-party implementation for these targets. So one of such moments we need to specify differently is concurrency, because Kotlin GVM concurrency is different and Kotlin native concurrency is different, iOS different, and Android different. There is not resemble. One of such cases when we need to use and work with concurrency, it could be working with networking. We know that when we use mobile application, networking is one of the most common cases when we need to use background working at all. Because there is no some hard calculation in mobile part. Of course, there is a lot of applications with animation or maybe something that use some kind of processing photos, but the most implemented case is using networking in our application. It's most common case. To use networking in common code, we can use Tool library, and it uses coroutines, but we need to And we also can specify differently networking and concurrency if we don't want to use common architecture and need to implement all this business logic separately. It could be the most easiest way to implement our logic, but if we would like to use uh, the best sharing experience in Kotlin Multiplatform, we need to specify our common model and using common concurrency. So let's take a look in our sample. I think it will be better and easier to speak about concurrency in Kotlin Multiplatform using one sample. So at first, let's take a look in simple networking with Ktor. It implements every kind of async working under its hood. When you use Ktor, you don't need to specify anything else except of some special details. Everything that should be implemented async is already implemented under the hood of Ktor. It uses some kind of native mechanism, and we will speak about this mechanism some slides later. Because when we don't need to use Ktor, we need to provide some kind of multithreading without some way. Without Ktor, but using some kind of logic. And we will speak about this logic. Well, in Android side, we can use coroutines. And what about iOS? Since Kotlin Native 1.4, we can also use coroutines in common code, and they will be easily and clearly transformed into Swift functions with a completion handler that has two arguments. One of them is your result, and the second one is the error. For example, if you have received some kind of error in your code. So let's take a look in common architecture and why we speak about common concurrency. Because I think that for most people, it will be easy to provide networking differently in iOS and Android and use coroutines for Android and maybe Grand Central Dispatch for iOS. But to provide the perfect experience of most shared code, we need to use common architecture. Here is a sample. We use common business logic with common networking service and common API service. Of course, here we need to use common concurrency, and it will be the work with coroutines. We also will use common scope for our coroutines, and then there is common architecture layer that is related for our business logic, and our iOS and Android native application uses this common business logic and common architecture. So let's begin. For Android, we can specify dispatchers for both main thread and for both background thread. Here is a sample. We can use default dispatchers default for background threading and dispatchers main for UI threading. Dispatchers main is unique for every platform, and how it works. There is some kind of fabric under the hood of dispatchers, and there is a main coroutine dispatcher, and this fabric will create or request the existing dispatcher for your platform. And if this platform is not supported, there will be no dispatcher. Same for background dispatcher. So here is a sample how to get main dispatcher from under the hood of your Kotlin native code. So we will not speak about Android because everything is fine with Android. JVM is similar for Android and for JVM. Let's focus in Kotlin native. So at first, let's try to use default dispatchers. For you, I will use dispatchers main, and for background also dispatchers default. If we will work with one context and our objects will be created in this context and will be local for this context, everything will be working fine. There will be no problem. But in common case, we send different objects between threads and contexts. For example, if we will try to use such kind of code, for example, we will switch our object between dispatcher default and dispatcher's main context, we will get such kind of exception. It is exception from CTOR, and the same you will receive when you will call your own code. So something was wrong. What is the problem? The problem is that we need to use our own code in dispatcher to be used as context. So there is some kind of recommendation. Let's try to do this. And now I will tell you why we use our own code in dispatcher. If you take a look here, you will notice that we re-implement dispatch function. In this dispatch function, we use our own code with global queue and main queue, that is native queues for Android iOS. And here we run the block of our code, and also there is some magic command freeze. How it works? At first, in our case, it will not working, but there was a recommendation that it will fix our code. What is the matter? So we cannot use dispatcher default because it is not bound to any background queue. We can use main dispatchers, but there is no solution for background threading. When we use CTOR, we can use dispatcher's main, and everything will be fine because CTOR already implemented every async work we need to do in our networking. But we will never, but CTOR is not the only case when we need background threading. And sometimes we want to use another solutions. So let's take a look next. When we work with CTOR, we will use in all these cases main dispatcher. And also we need to specify first command, and now everything should work fine. Why we will specify freeze? There is one rule that in Kotlin native we need to work with immutable objects only when we work with multiple threads. And we can use mutable only in one thread. So mutable should be local. In Kotlin JVM, everything is okay. There is no such problem at all. So to make our object immutable, we use freeze. But in our case, we have received freeze exception. What's happened? The problem is, yes, and also there is such kind of solution, and it is really outdated solution, and I will not recommend you because also it uses dispatch get global, and we know that it is not bound to any particular thread. So why we use threading? What will not working with our freezing? We need to specify thread local because our dispatcher is singleton, and singleton is already immutable. So in this case, we need to make our singleton usable between all threads. So it will fix everything. What is other solution how to use background threading when we don't need to use CTOR? When we use main dispatcher, there is something that is bound with main scope of coroutines. And there is also a global scope. For every iOS developer, global scope is equal to global queue, as main scope is equal to main queue. But using global scope is not recommended because it will be not so easy to manage all the coroutines of the job we do in global scope. To fix it, we need to collect all the links to our jobs, and then we need to listen to the end of all our jobs, and then clear the links to our and references to our jobs. It is just kind of workaround. But in main case, global scope is not recommended at all. What we need to do? Yes, here is my last slide about frozen exception with singletons. And here we provide thread local. It is a magic annotation that will fix the work with our singletons, objects, and companion objects. And in these cases, everything will work fine. So now let's take a look how it could be done without coroutines and without KTOR. Let's take a look in native mechanism that KTOR uses under its hood. So when we use different implementations for concurrency, because our platforms are really different, we can also using different types of synchronization for our work. For example, we can also specify synchronization as expect actual and implement it differently. In iOS, we will use object sync enter or object sync exit as a mutex, and between these blocks we will provide some kind of our code, and here is below an example how we will do the same with try synchronize that we use in Kotlin and for Android. So there was a just small sample that thread saving is also really different for iOS and Android. So now take a look in our sample. We will provide some kind of own networking without KTOR and coroutines, but using some kind of native mechanism managing threads. So we remember that networking is a common case for coroutines, or for concurrency, I'm sorry. So it will be small network clients. And here is a sample how we need to implement network client for iOS. You can see some kind of Kotlin code with some kind of perhaps unknown commands for you, but it is same implementation that we will do in Swift for iOS, but in Kotlin, because it's Kotlin Multiplatform, and it is specified in iOS main code. So Android has its own implementation. We will not look at Android. And now we need to specify some kind of some tricks to make our code working. At first, we also need to freeze everything that will be switched before threads. And also we need to provide some kind of solution to put our code and be invoked from background and then transmitted to main thread. So here we will do this. We will use mechanism of background worker, and it is a special mechanism in Kotlin native, and here is a sample. Worker could be created with worker start command, and then for this worker in execute block with parameter trans mode save that will provide for us thread safe work in our threads, between our threads and switching our contexts. We need to at first we need to freeze our code and then call it, and it will produce some kind of feature. We need to collect to prevent memory leaks. So how it works, and you can see that it is a kind of block without an answer, and we can specify it here. So here we will call our void method. And how about return to main? So also we can specify the callback where we could return our result of the result of our code. It will be called from future consume part, and here in callback we could put the result of our work. But it is not about switching to main. Maybe perhaps here we can put this one or not. To provide the wrapper in main thread, we can use the same approach we used before for dispatcher main, for main dispatcher in iOS. And here we at first freeze our block, then we call next method, and in callback we also specify the queue where we need to invoke our freeze block. And we will wrap at first the result of our consummation. And it seems to work at first sight, but we have forgot about several cases. We have frozen everything, but when we need to collect the answer, we should make it unfrozen. And how to do this? If we will stay everything as it is, we will get invalid mutability exception. So we need to do something. How to deal with mutables? To do with this, so what is the problem with our crash? When we receive all the data from our networking, we need to collect it in several arrays. So it is the same array, and in several iterations we will get the portions of data, and we will add it to our array. But our array is frozen, and we cannot change the frozen because frozen is immutable. To do this, we cannot use thread local. Thread local is only for objects and singletons or backing fields, but we can try to implement it our own way. For example, Ktor uses such kind of delegated property for thread local, but it's not our case because if we will take a look, it already implements frozen, and this is why the problem we have at the moment when we try to freeze it one more time. So, and in this case, we will get only frozen exception, so it's not our case at all. To deal with mutables, or to make immutable mutable again, we need to use atomic reference. It is a special kind of wrapper. To keep our variables, we need to keep mutable. So we need to use atomic reference, and here we'll put the frozen block of our code or our frozen variable. And we also need to specify clear of this reference, because without it we will get memory leak. So let's fix our code. We will create some kind of atomic reference to our array, and then in special method where we'll get all the data, we create mutable new array, and we at first get everything from our old array, and then we will add the portion of new data, and then we create immutable frozen reference to our new array and add it to previous array. So everything works fine. And also don't forget about clearing, but in this case it's better to make an empty array. So, and there is one more moment how we can work with mutable and sharing. We can use detached object graph. It is a special kind of graph that let you share data between threads, between contexts. You need to create, for example, some kind of default future as your answer, and then you need to specify detached graph as a pointer. In this detached graph, you need to put your output, your input, the link to your methods, the link to default future to get the result, and then to keep it as immutable, and then you need to keep a pointer to your detached graph. So you need to do it in the beginning, and then you need to get to your special queue, for example. For example, it will be dispatch get me a queue, and here you need to work with this pointer. To work with it, you need to attach it, and you can attach it only one time. So when you have attached the pointer of the graph, you can get all the parameters and arguments from this attached variable, do something with them, and then put the result into the result output block. And at the end, you need to return the deferred. And if you want uh, to work with your detached graph several times, you need to create a new detached graph pointer every time, because the pointer could be used only one time before you will attach it. So it's some kind of really advanced and extended mechanism. It looks too complicated, I think so. Let's return to coroutines to return all our results. To communicate between our contexts, we can use such mechanisms as channels, flows, completable deferred. And I think it will be really nice to implement it as a receiver and sender of our answer to the user. For example, we can use completable deferred to collect all the data from our engine, and then turn it to our user as a immutable variable. So here is a sample how it could be done with channels. And also we can use here mutable state flow. Mutable state flow is universal for both Kotlin native and Kotlin Android. So it could be done the same way. Also, we need to specify here to work with scope, our own scope for this block of code, or maybe to send the scope as a parameter from another part. You can do it in your favorite style, for example. And yes, we can send this. I think that it will be nice here to provide own scope for iOS. So perhaps it's not really correct, but it could be done just like this when you need to provide only some kind of isolated logic. So let's take a look at this sample. Oh, and now let's take a look how we can use flows in iOS part. We have talked about how to use suspended functions inside of Kotlin common and inside of iOS, but how can be done the logic with flows? So why we will not use live data? Because live data is Android only, and everything that is platform special only couldn't be used in common code. In this case, we can use mutable state flow. If you will take a look at sample in slide, so it is not view model from Jetpack, but it's some kind of piece of code that is common view model that could be used as in iOS side, as an Android side. So we use mutable state flow to collect the data from our networking. And we know that we can use it easily in Android side, but what about iOS? In iOS, to collect the data from flow, you need to implement special kind of flow collector. So it is a sample how it will be called at first from iOS side. So you need to implement special class that will derive Kotlin Next Courteous Core Flow Collector and re-implement a meet block. Also, you need to put here completion block to send it as a result from your work over the flow when everything will be emitted. And sometimes signals could be missed if you will not set up your collector correctly. So another way to use flows is to create in Kotlin common part some kind of flow wrapper, and this flow wrapper will implement all logic with coroutine scope under its hood, and user will get only some kind of suspended completion block, so it will be blocked with completion handler as a completion. So how it could be used from iOS part? So let's think that it's already created flow and there is collected, and in completion block you only print that everything is completed. So, and in collected block you will get true result. So everything is easy. Now let's take a look at new memory management model. When we talked about Kotlin native and its original ways to work with background threading, we faced several hard moments. For example, it's not clear how to use sharing, it's not clear how to use freezing. For example, there is not only atomic reference but freezable atomic reference, and when you will search for a sample and see some kind of detached object graph, it could be really hard to understand, for example, for you. And we know that when we use tool, we could provide on local and some kind of own dispatcher, and it will be enough for us. But to implement it by ourselves without any other library, we need to do a hard work and to implement our own toolkit to provide all multi-threading and concurrency. So new memory management module will solve all our pains and problems. The main point of focus of this new memory management model is safe sharing and changing the thread context correctly. At first, we will remove every block with freeze. We don't need freeze anymore. Also, there is no leaks in atomic reference and freezable atomic reference. You can use them without any pitfalls. Uh, also, we also there is no need of shared immutable. When we use singletons, we use thread local, but for globals there is shared immutable annotation, and we don't need it anymore. And there is no isolated graph of dependency when we work with workers. So what's else? When we work with atomic reference, they still need to be freezed. And we can use freezable atomic reference instead. The globals are lazy, but if you want to initialize it immediately, you need to use eager initialization. Also, there is some pitfalls. There is no guarantee that your suspended block will return everything to main. And the init could be called in other threads. So there is some hard moment, but if you will use dispatch main in your iOS site or just use context with UI dispatcher, everything will work. So let's take a look in our code. To migrate from our current concurrency model to new, we need to specify a special version of Kotlin. It will be 1.6 or newer with M1 suffix. Also, we need to specify and use special version of coroutines from special branch. And if you would like to use libraries to support new memory management model, they also should be from the special version. And if you use it in iOS, you also need to use Xcode 12.5 or newer. So let's transform our code. At first, let's remove all freezing. Let's remove all freezing block from non-coroutine version, from all the backgrounds and main. Then we will remove all freezing from our other part of code. We don't need it anymore. There is no freezing. And one point of magic, we will also remove all freezing from our flows and channels. We don't need it anymore. We will use freezable atomic reference without freezing, and everything will work fine. Yes, here it is. And yes, here is sample how we will collect our data. We don't need freezing anymore. We just collect and add our data to our array. Or perhaps you don't need some kind of swapping array. You just can add some kind of data to your original value, and it will be fine. What else? One of the main points of this new feature. For iOS and Kotlin native, we can use default dispatchers. There is default dispatchers for main case and default case. And let's take a look how it works. If you will create a coroutine with IO dispatchers or maybe some kind of dispatcher, so it's just a naming of your variable, but use dispatchers default or dispatchers IO, and call some kind of coroutine here, and then print the output, you will see here magic words, Darwin Global Queue Dispatcher. It means there is a coroutine, there is a dispatcher and context bound to our iOS global queue, and it is super cool. So we can use default dispatchers, and we don't need to provide our own solution and struggle with if we have forgotten to use freezing here, or maybe there is some kind of wrong queue, and we have forgotten that we could use only dispatch queue main, and we cannot use dispatch queue global with some kind of quality service. So we can use only default mechanism in coroutines. And to specify correct context, we will switch our result to UI dispatcher to be sure that everything will be transmitted to our main thread. And there is also a recommendation from authors that we need to provide auto-release pull wrapping in order to prevent memory leaks. This API still be developed, so there could be several distinctions, and here could be several moments that will be improved. One of these is memory leaks, and another one is garbage collection. And what else? There is special kind of context we can use to create our own coroutine context with own working dispatcher inside of it. This is new single thread context. We know that we can use such kind of context in Android Kotlin side, and it worked perfectly. But now we can use it also in Kotlin native, and it works fine. In output, you can see that there is a special kind of working dispatcher. It is unique dispatcher for this thread. And there is one more moment. Not all libraries at moment support correct version of memory management model. Because new memory management model is not stable, and in the most of our libraries, we prefer to use stable version of libraries because it's not only our pet project but our work, and our product manager will not be happy if our application will work strange and wrong, and the customer will be disappointed. So if we need to use stable version of our libraries without new memory management model, we need to specify freezing disabled. So we need to disable freezing at all because we need to provide own freezing old way. We can disable freezing just like this with these two instructions. For example, we can specify it in Gradle properties, or, oh, I'm sorry, there is Russian command in my slide. Or we can specify and build KTS script and just put disabled value in freezing option. So, and let's summarize up. I see that it's correct with time, and we have also time for questions. So let's summarize. Concurrency in Kotlin native could be really hard. It's harder than in Android, and it's really hard to implement correct common solution. Uh, we we have spoken about Kotlin native concurrency, and we understand that these solutions we can implement only in iOS main or native main if we will work with desktops, but it will not be it could not be used in common parts, so it will be only in not for expect but for actual part of your iOS main or native main code. And for Android, it will be implemented differently. So we know that it could be, for example, two current contexts, and will be some kind of easy switching between them without any problems at all. And it's really nice that Kotlin native provide full toolkit to implement all background threading without any other libraries. And the memory management new way will solve all our pains. We're waiting for this, and it will be stable and released this year. And one of these improvements will be leaks and garbage collection. Everything will be okay. And we need to wait the stable version. So here is several useful links, and thanks for listening. I'm ready for your questions.
Okay, I think we have three questions. If you can
Mhm.
take a look at the Q&A, is it visible to you?
Yes. What's better to use for Android developer, Kotlin or Flutter? Well, my favorite, my favorite kind of questions when I speak or some another person speak about Kotlin Multiplatform. What is better, Kotlin Multiplatform or Flutter? So it depends of what you want to develop. For example, Kotlin Multiplatform is a perfect solution if you need only to use common memory. I'm sorry, common business logic and common code. But when you use Kotlin multi-platform, you need to implement your UI part differently, and it will be holded not in iOS main or Android main parts of your application, but it should be provided in iOS project and Android project that will use your common model of code. And Flutter it is a full-fit framework with its own mechanism working with UI, but there is also several tricky moments how to implement adaptivity, for example, and uh, there is also several problems how to implement platform-specific logic. I haven't worked with Flutter, but I was an Xamarin developer for 4 years, and I struggled a lot with these renderers when you need to specify them in common way and then re-implement it in iOS and Android differently. Took it took a lot of time. So, if you would like to implement easy kind of application with some kind of common UI, of course you need to use Flutter. But if you would like to implement UI with an application with hard UI, with some complicated UI, I'm sorry, I have forgotten this word, complicated. Uh, you need to use Kotlin multi-platform and implement your UI and platform-specific code differently for iOS and Android. Do we only need to use atomic references when working without coroutines? Atomic references is mechanism from Kotlin native. Um, I think so. When you So uh, we there was a sample when atomic references were used with coroutines. When it was a moment with old memory management, and here we used coroutines to work with the flows and channels when we have collected all our data. Also, also you can use some kind of sharing with your channels of flows. But when you use all memory management, your channels should become from immutable mutable. So yes, you can also use it with coroutines. Did you make some experiments comparing with other hybrid platforms? Well, yes, I was Xamarin developer, as I said before, as I mentioned before. And for me, Kotlin Multiplatform is a really perfect kind of solution when you need to provide common business logic. I'm not a fan of common UI at all. Uh, where will the recording be uploaded? So is perhaps it's not for me question.
Yeah, it will be uploaded on YouTube, and you can follow us on Twitter, so you will know when that will be uploaded.
Uh, I s- so I have forgotten. How do you handle the errors from Kotlin memory code when called from Swift? Do you use exceptions or something else? Of course, I use exception handling in common code. I prefer to collect my errors here in this part. So there is also catching exceptions, and also when I work with networking, use some kind of my own written wrapper where I put both my result and also my error wrapped in some kind of um, model for more comfortable use in my code. So I prefer to work with all errors in common code and not to send them as raw error in iOS or Android. So it will be only wrapped and processed error that I will use, for example, to show some kind of dialogue with this error, or maybe for some kind of action in platform side. Um, I saw you were using some EAP version for using Kotlin Multiplatform new memory model. However, I remember not noting that coroutines 1.60 would use new memory model out of the box. Do we still need to use the native MT version of it? Uh, well, um, I uh, I showed you the way to migrate from old memory management model and to new memory management model. And of course, when you use some kind of um, old libraries, when you at first use new libraries with new memory management model, you need to specify special versions of these libraries as a most stable and tested for these purposes. So speaking me, I prefer not to use. So I also used 1.6 coroutines, but I have also remember that there is also special kind of branch, and the same was with old memory management model. So there also so when you used old memory management model, there also was a version of coroutines without MT, and you could also use it with your iOS part. But in MT versions, there also was some kind of different processing of memory management. This is why it is better to use MT versions for such kind of experiments. If I am middle Android developer, do you recommend to learn Kotlin multiplatform? Of course, I recommend it because it's also will be useful for you to learn how to become iOS developer, and when you know how to do not only Android but iOS, it will make you more flexible as a developer, and it also will let you to understand better the platforms and the specific between them. Um, so after Ktor native retrofit Alamify is dead. No, no. uh, you can also use it with your native applications. I only shown you the sample for Kotlin Multiplatform. You can implement your own Kotlin multi-platform model with only, for example, mm, data models, and you can specify here the common interface for your network service or some kind of other service. And here you can also bound your native implementation from your native projects when to set up the entry point to your memory to your main model code. And you can specify also a retrofit in Android side, in LMFI in iOS side. Speaking me, when I develop iOS application, I use only native URL session approach, because um, there is one tradition that when you implement and develop some kind of really serious application, and just and you need to provide some kind of security in your application, it's better to do it without third-party libraries at all. Do you recommend a good tool resources? Of course, I recommend it because it's a really universal library, and uh, it let you to create networking in your Kotlin memory, in Kotlin multi-platform and Android application easy way. Ktor provide several samples how to use their libraries, and it's a really good library. I was speaking about Ktor only in context of Kotlin native, and because I'm interested in n- not only Android Kotlin memory, Kotlin multi-platform work, but in iOS.
I think he was asking for any resources that he could avail to learn KTOR or how to use KTOR. So if you have any,
I
please share them.
Well, I think that to learn how to work with Ktor, people need only two resources. First is the main site of Ktor, and the second one is the GitHub of Ktor. And they let their code open, and you can download the repository and see what was done here. For example, I did the same when I was interested what was done and what was implemented in Ktor under its hood. Is it possible to specify where memory is going to be allocated? Can we specify a data class to be allocated only on stack and not on heap memory? Perhaps it is possible for JetBrains developer, not for me. So it is not open at the moment for people who are only users of this library. Do we need to be expert in any language? I see myself stuck in between Kotlin, updated Java APIs, Flutter framework, Jetpack, UI, and other demanded languages like Python. It depends of what you would like to do as a developer. I prefer to be a specialist only in mobile development, and for me it's really comfortable to work with Swift, Kotlin. They looks really same and resemble, and it's really easy to switch from Swift to Kotlin and from Kotlin to Swift. So it's really perfect to switching from iOS to Android and from Android to iOS. If you would like to be a cross-platform developer, you can try to work with Flutter, but to work with Flutter and Kotlin multi-platform, you need to learn at least one platform at all. For example, Android or iOS. For example, it will be easy to begin with Android and then to switch to Flutter, or try Kotlin Multiplatform as addition to your Android application. Python and other things is really different from mobile development, and you can know them briefly to be good educated, but to become a really good level developer, you need to choose one specialty of you and then improve your knowledge in this direction. Uh, could you post the links to the repo you mentioned? Repo Ducto or my own repo? I will send the presentation and it will be shared uh, in Twitter. And in this presentation, you can find all the links. And also under my tweet, I will keep the links to Cto, for example. Do you have tips on how to do dependency injection with Kotlin Multiplatform? I have implemented sample library to do manual dependency injection in Kotlin Multiplatform. And now I work to work with plugins in automated dependency injection, and also I tried to implement it with Kotlin simple processing. So also it was a kind of talk on last July here in Android Worldwide, where I presented how to use Kotlin simple processing to work with annotation in automation of dependency injection in Kotlin multi-platform. Also, there is a lot of different sources, for example, Coin, or maybe yes, Coin is really nice solution, and they also implemented their good solution to deal with Kotlin simple processing for the automated dependency injection.
Anna, I think we are a bit out of time because we have
Yes.
next speaker as well. So, to the audience, any more questions you have, please reach out to Anna, or you can join the Android Worldwide Slack workspace and you can reach out to her there as well. So, there's a small update. One of our speakers, I think it's the talk, two talks after this one, which was going to be given by Sinan. He is stuck somewhere on the airport due to some climate, some extreme snowfall or some situation like this. So he's stuck, and he will not be able to present the talk. So we have updated our schedule. So if you're looking forward to that talk, I think this that talk was on UI testing and instrumentation. So that has been changed now, and there we have a superhero who just came last minute speaker, and he is now going to be presenting on, I think, Firebase and improving quality with the Firebase project. So that's a change in schedule. And I'm going to end this session, and we will start the next session with Russian Jode on SQLite performance. Cool. So thanks, Anna, for being a wonderful speaker, and audience, thanks for listening to this talk. And we will meet in the next one in a couple of minutes.
Bye, everyone.
Bye.